Let's consider the ocean. It's vast, covering more than 70% of the Earth's surface. As with the sun and the great mountains, it's difficult for humans from our small perspective to comprehend exactly how big the ocean actually is. It seems never-ending, and this leads people to underestimate the effects of man-made pollutants in marine environments. For instance, we all know it's not smart to swim in the ocean right after it rains due to runoff, but a couple days later, everything's been washed out to sea, right? While this isn't entirely false, coastal ecosystems retain a fraction of these anthropogenic pollutants, and over time, these build up to toxic levels. Toxins enter the food chain at the lowest trophic level and travel up the food chain as big fish eats little fish. Microorganisms are consumed by phytoplankton and zooplankton, which are in turn consumed by a prey fish, like the sardines we have here in Southern California. From here, a larger predatory fish like a sea bass or yellowtail will consume the sardines, and then, if they fall prey to an apex predator, like a marine mammal, the toxins will continue up the food chain. At each level, the toxins passed on through the ecosystem, and this process is called bioaccumulation. Yet, there is more at play here. At each trophic level, the concentration does not stay static. It increases exponentially, meaning that the apex or sentinel species develop dangerously high concentrations of an accumulating toxin in their fat deposits. And this is called bioaccumulation. Predatory marine mammals, pinnipeds and cetaceans, are especially susceptible due to their diet and their long lifespans. The first question to ask is, what materials bioaccumulate? For a compound to be bioaccumulative, it must be long-lasting and slow to degrade, so that it sticks around in the food chain for many years. Also, it must be soluble in lipids, for nonpolar compounds get stored in an organism's fat deposits. Polar compounds, if consumed, just get eliminated from the body pretty quickly. And for a chemical to be harmful, it must be in some way biologically active. There are two main categories of bioaccumulative compounds affecting marine ecosystems. One of these is heavy metals, which enter the ocean mainly through emissions, but also in runoff from coastal mines. Let's focus on mercury. It's the most studied due to all the health issues associated with it. Mercury enters the oceans in its inorganic form, and it's converted to methylmercury by anaerobic bacteria. Methylmercury is a known neurotoxin and easily becomes magnified in marine food chains, affecting sentinel species and in turn all of us. A recent study conducted by researchers at the University of California, Santa Cruz looks further into this issue. Researchers measured methylmercury concentrations in the waters of Año Nuevo State Reserve elephant seal rookery in Southern California. When comparing these concentrations to those at nearby beaches, the researchers determined that through moltage, elephant seals are acting as vectors, concentrating methylmercury in the waters where they live. Here are some numbers to add a little perspective. I took the recorded values from the Santa Cruz paper and calculated the concentrations of methylmercury in both the state park and the San Francisco Bay. Año Nuevo is a pristine marine reserve compared to the San Francisco Bay, which is surrounded by industry and is used heavily by boats. The concentration of methylmercury in Año Nuevo ended up being slightly greater than that of the bay, showing that the seals are contaminating their rookery with accumulated methylmercury. This essentially means that accumulated methylmercury is being funneled into highly productive marine ecosystems through top-down contamination. These ecosystems often support major fisheries and are a draw to recreational swimmers. I live in San Diego, where I often swim alongside seals. I wonder if they too are increasing mercury at our beaches.